Hey everybody, today I just want to share a little video. I had someone ask me about doing speech to text in LabVIEW, which there's really not something out there for that, so I was doing some messing around trying to find something that would work well. I looked at, .NET, there is some stuff out there, but I couldn't really find anything great, so I actually went down kind of a Python route, and then I actually have two methods, I guess I should say. So one of which uses Python, one of which is LabVIEW basically. So I'll show both so we can see, and then all of this code, the link to the repository is just down in the description if you want to download it and play with it yourself. So this is our first example I wanted to walk through. So we're just using this speech recognition library. So we're going to connect to, so we're going to connect to our microphone right here. So we're using the microphone as our source. You can also use this library with just an audio file. If you have like an MP3 or a WAV file or something like that, you can just upload that directly using this tool as well. Here I'm just pulling from the microphone, and I'm gonna say that I'm listening for some period of time, right? And then just this function here, I'm just taking one argument that is basically how long to wait. Once you call this function, it's going to capture audio for a period of time and then try to transcribe that. So that way you can kind of customize how long it listens for, whether that be, a couple seconds or a minute or whatever. And then here we're just, adjusting for ambient noise. So trying to, just kind of filter out some of that background noise. And then this is where we're actually doing the, speech recognition, right? And this speech recognition toolkit in Python is actually really cool because it supports a whole bunch of different speech recognition technologies. So here you can see I'm using like Recognize Google. So this uses Google's speech recognition, which obviously requires that you have a connection to the internet. If you look at the package documentation, there's actually a ton of different ways you can do this, and some of them actually work offline. So if you have like an offline system that you need speech recognition on, there are ways to do that. I'm using Google here. It's nice because it doesn't require like an API token or anything. It's quick and easy, and it's actually been working really well as I've been testing with it. And then I have just some, hey, if the speech is, unintelligible, just returning some text that basically gives some information, right? So like, if I send some microphone data and the API can't understand it, it's going to respond. I'm going to get this printed out instead. And then same thing, if the request is unsuccessful, let's say maybe you're not connected to the internet or something, you'll get that there. And lastly, this final exception. Pretty simple. This full .py file is in the repository if you want to play with it. Just want a demo. So let's run this. Can you hear me? And there you go. So listen for 5 seconds, transcribe the text that I heard. It works great. So I went ahead and just demoed how you can call this directly in LabVIEW. So I'm just using Python nodes here. So this is just the OpenPython session function, and I'm just passing in the specific version of Python I'm using, which in this case is 3.12. Here I'm just setting this little listening flag true, to let you know once I've connected to the Python session, and we're ready to call the function now. And then I'm just calling this simple speech py. The function is listen and transcribe. I've defined that the return data is a string, and the time to wait is a field I can pass in, so I can customize how long it actually listens for. And then I'm just turning that off when it's done. And there you go. So I've run this. It works fine. I have noticed just a lot slower being called from LabVIEW than it is running it in like VS Code or something. But nonetheless, it's worked fine. So, and this LabVIEW UI is also in the repository if you want to play with it. So yeah, and then kind of a little bit more mature example. So I've gone ahead and created something that you could use for like continuous transcribing of text. So that other one is like your one shot, right? You know, you say, hey, start listening for this period of time, and then it transcribes that. And that works great if you just need to hear something. But maybe you want to be continuously transcribing text. So what this is going to do is I've created a class that you can call, and this will require that you're using LabVIEW 2022 or newer, one of the ones that the Python nodes support objects. But yeah, basically this way we can start the streaming, and then we can continuously read data using sockets. So yeah, I mean, we're basically doing the same functionality, right? So we're a lot of the same stuff we were doing before. Just now we're going to be opening a socket asynchronously. So we're creating a separate thread that's actually going to be managing connections and stuff like that. Yeah, if you notice, this all looks, just about exactly the same, right? So we're, listening to that data using the same Google speech recognition. Just then we are sending that data over a socket. So that way in LabVIEW, you can start the basically recording and streaming, and then collect that data. And then basically when you're done, just call the stop streaming function. So I don't want to demo this one because I have one other example I wanted to spend a little more time on. But yeah, this class and this whole .py file is also in the repository. So the last thing I wanted to demo was one that doesn't require Python. So I have this example here, and let's just clear this graph. So yeah, basically I can specify how long I want to record audio for, and then I have this graph that's just displaying the actual audio data, not anything super meaningful for this application. And then down here is where we're actually going to read out the text of what I said. So let's look at how I'm doing this. So we're going to start out by using just the basic, if you go to graphics and sound, just these functions here. So we're going to be using the input functions to read data from a microphone, and we're going to be using the file functions for recording to a WAV file. So here I've just got this generate temporary file path function. That's just going to generate an temporary WAV file path. And then I'm using the sound file write open to basically store, my basically metadata, right, of like, the sample rate, channels, stuff like that. And then here I'm using the sound input configure to just connect to the default microphone, and specifying the number of samples per channel and the same information. And then in this loop over and over again, I'm just reading data from that microphone. So I'm just using the sound input read and then just pulling that out, graphing that, and then writing that to a sound file. And down here, all I'm doing is checking to see if enough time has passed, right? So basically, if I say 5 seconds, has 5 seconds passed. And when 5 seconds does pass, then we're going to stop this loop. And yeah, when we're done, we're just going to close that, use the sound input clear to close out that session to the microphone, clear the buffer. We're going to close that session to our file. And then lastly, we are going to set busy while we use this speech to test function. And that's just going to stay busy until it's over. So if you look in our speech to test function, so this is connecting to Assembly AI. So we're actually using an AI cloud service that allows you to do speech transcription. So nice thing was, this is free. I think there are limits on what you can do free, but I haven't had to pay for anything. I didn't even have to input like credit card information or anything. So that's nice. So yeah, I'm just using HTTP functions. So I'm just creating some headers, right? My authorization using my API token, my content type, and then I'm just doing a post of the file. So this is just going to upload. All this code right here is just uploading that WAV file that we just created. Then I'm just going to do some simple parsing of the JSON to get the now upload URL. So once we've uploaded the file, we then need to transcribe the file. So we're going to issue another request with our same thing, API token, and our content type this time is going to be application JSON. Our endpoint is a little different now, so we're going to the transcript instead of the upload, and we're using a post buffer to actually write this audio URL, right? So yeah, just creating an object out of that and writing that. So we're saying, hey, we've uploaded this file, now transcribe it. And then I have added a delay here just because obviously the transcription isn't immediate. There is a better way to do this. You actually can, if you use the retrieve transcription, and I'm not parsing all of the JSON. There's actually a lot more information than what I'm doing here. Just this is a simple example. But basically it can read the status. So it can let you know if the transcription is still processing or if it's pending or if it's done. So a much better way to do it would be to basically just, read this, see when it's done. I just have a hard-coded wait here for testing. That works fine. But yeah, you can actually read its status so you know exactly when it's done. So if it was done in like 1 second, right, I don't need to wait 5 seconds. Or if it took 30 seconds, right, here I would get an error. So obviously it could be handled better. There actually is some other cool details here. So like I'm just pulling out of this JSON the raw text, which there's actually a ton more details. So it actually will break apart word by word and give you like a confidence rating for each word. So you can see like which words were highly confident and which words were not. Lots of other cool details. So yeah, there's a lot you can do with this. So yeah, it's all assembly AI. Just make an account. You'll issue yourself an API token, and then you can just plug that in and use this. But yeah, this is just going to parse the response and basically extract the text that is our transcription. So let's go run this and see what it looks like. Okay, so here's our VI. Thanks for watching. Sweet. And there's our transcription. So it's actually really fast. If you look at their website, there's a whole bunch of documentation about how it can process like pretty long audio files in a matter of seconds. So I don't know if the 5-second wait is overkill or not, but just FYI. So you can see here's our transcription. So yeah, here I'm able to basically do it all from LabVIEW per se. So the actual reading from the microphone, recording to an audio file, uploading the audio file, and then retrieving the transcription. So obviously Assembly AI is doing the actual transcription work, but it's a way you can kind of remove that Python dependency as well and not really rely on that. So yeah, those are a couple different ways that you can do speech recognition or speech to text in LabVIEW. The code for all of this is in the repository in the description. So if you want to play with it, make changes, do whatever, feel free to do whatever you want with it. But yeah, hope that's helpful, and thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.